Assalamualaikum. Today our team will present about non-conventional process. My name is Syed Adam Kevin bin Syed Fakul Zaman.
And my name is Syed Johan bin Syed Fakul Zaman.
And my name is Muhammad Mafiq bin Muhammad Haq.
So firstly about introduction. Non-conventional processes are innovative and unconventional manufacturing methods that differ from traditional approach. Example of non-conventional process include 3D printing, laser cutting, electrochemical machining, and ultrasonic machining, which utilize advanced technology as CAD/CAM software and robotic automation to achieve high level of precision and efficiency. Gaskets are chemical devices that are positioned between two or more surfaces to prevent the leakage of gas or fluid when compressed. Minifigures are small plastic figurines that are popular among collectors and fans of building block toys. They typically stand around 1.5 to 2 inches tall and are designed with movable limbs, head, and hands, allowing for various poses and interaction with other minifigures and building block sets. Minifigures are popular among children and adults alike and are often collected and traded among fans of the toy genre.
Next is the question EDM wire cut. Material, metal. Metal is an ideal material for EDM wire cut because it can be difficult to machine using traditional method due to its hardness, tightness, and heat resistance. EDM wire cut can cut through hard metals such as hardness steel, titanium, and tungsten carbide, making it a popular method in the tool and the industry. It is also used to cut interaction and contrast in metals that are difficult to machine using conventional methods.
EDM wire cut. EDM wire cut are defined as a cut machine, also known as a wire EDM or wire cutting machine. It is a non-conventional manufacturing tool used for precision cutting of complex shape and contour in electrical conductive material.
So this is example of EDM wire cut. So EDM wire cut is called as electrical discharge machining. It's a non-conventional manufacturing process that uses electrical spark to remove material from a workpiece. EDM wire cut, also known as wire EDM or WEDM, is a type of EDM that utilizes a thin, electrically charged wire to cut through the workpiece. The wire is guided along a pre-programmed path using a computer control system that ensures high precision and accuracy. This process is commonly used for cutting intricate shapes and contours in hard or exotic materials that are difficult to machine using traditional methods. EDM wire cut is widely used in industries such as aerospace, medical, and automotive for producing complex parts and components with high level of accuracy and surface finish.
This is flow chart. This is our drawing. Information data process. The wire EDM process by following steps. Material preparation. The workpiece, which must be electrically ductive, is prepared by cleaning and positioning it in the machine. Wire installation. A thin electrically charged wire is installed in the machine and thread to a set of precision cards that control its movement. Programming. The machine is programmed with the desired cutting path, which is based on a computer-age design CAD model of the part. 4. Cutting. The machine uses the electrically charged wire to arrive the workpiece. Remove material layer by layer until the desired shape is achieved. The wire is guided along the program cutting path by a computer control system that ensures high precision and accuracy. 5. Finish. After cutting is complete, the workpiece may undergo finishing operation such as polishing or hard treatment to achieve the desired surface finish or mechanical properties. 6. Wire replacement. As the wire is arrived during cutting, it must be periodically replaced with a fresh wire to maintain cutting accuracy.
The standard operational process for EDM wire cut. First, the precision. EDM wire cut machines are designed to produce precise cut with tolerance in the range of few micron. And then the second one is surface finish. EDM wire cut machine can produce a smooth, uniform finish with minimal roughness. And then the third one is material compatibility. EDM wire cut machine can be used to cut a wide range of material. And then for the safety, EDM wire cut machine must be equipped with safety features such as interlock. And then the last one is reliability. EDM wire cut machines are designed for continuous use and high productivity.
Next is parameter process. So this is the parameter process for EDM wire cut. Firstly, material. Choose the appropriate wire type and the meter for the material being cut. Next is wire tension. The wire tension should be adjusted to suit the material being cut with a higher tension for harder material and lower tension for softer one. Next is flushing. Ensure that the flushing system is set up properly to remove debris and maintain consistent cutting condition. Next, cutting speed. The cutting speed should be adjusted based on the material being cut, with faster speed for softer material and slower speed for harder ones. Next, power setting. The power setting should be adjusted to suit the material and thickness of the gasket. Lastly, finish quality. Adjust the parameter to achieve the desired surface finish quality.
And the advantage of EDM wire cut is first, precision. EDM wire cut can be produced highly precision, cut with tolerance as tight as a few microns. 2. Versatile. EDM wire cut can be used to cut wide range of material. 3. Not to wear. Unlike traditional machine method that's rarely on cutting tool. 4. No thermal distortion. Since EDM wire cut does not generate heat. And 5. Excellent surface finish. EDM wire cut can be produce a very smooth surface finish with minimal rough, eliminate the need to secondary finish operation. And the last one is automation. EDM wire cut can be automated, which is can improve productivity and reduce labor cost.
And for the disadvantages, while EDM wire cut has many advantages, they also have some disadvantages. For the first one is slow cutting speed. EDM wire cut can be slow compared to other machining method. And then for the second one is limited material thickness. EDM wire cut not suitable for cutting very thick material. And then the third one, high equipment cost. EDM wire cut machine can be expensive. For the fourth disadvantage is wire breakage. The wire used in EDM wire cut is thin and can break easily. And limit for the fifth one is limited surface finish option. While EDM wire cut can produce a very smooth surface finish, it may not be suitable for creating certain surface texture or finish. And then the last one is environment concern. EDM wire cut can generate waste material and consume significant amount of electron which may contribute to environmental issue and higher energy costs.
So for defect, taper. Taper is a common defect that occurs when the wire cut is not perfectly perpendicular to the workpiece, resulting in a tapered cut instead of a straight cut. Next, roughness. Roughness can occur if the EDM wire cut parameters are not properly adjusted, resulting in a rough or uneven surface finish. Next is wire breakage. Wire breakage can occur if the wire is not properly tensioned or if the cutting conditions are too aggressive, resulting in a broken wire and potential damage to the workpiece. Next is corner rounding. Corner rounding occurs when the EDM wire cut does not accurately cut sharp corner, resulting in a rounded corner instead of a sharp angle. After that, overcut. Overcut is a defect that occurs when the EDM wire cut is too deep, resulting in a cut that goes beyond the desired depth and potentially damage the workpiece. Lastly, undercut. Undercut is a defect that occurs when the EDM wire cut is too shallow, resulting in a cut that are deep enough and potentially compromising the accuracy of the workpiece.
Question 3D printing. The material is thermoplastic. Thermoplastic are a type of plastic material that can be made and reshaped multiple times when heat and cooled without undergoing a significant chemical change. That this make them a versatile and widely used material in various industries, include automotive, aerospace, packaging, and consumer goods.
In the machine, they use a 3D printer. A 3D printer is a type of manufacturing device that uses computer-aided design, CAD, software to create three-dimensional objects.
So this is an example of 3D printing. So the method, a 3D printer is a type of non-conventional manufacturing machine that creates physical object layer by layer from a digital model. This process, also known as additive manufacturing, allows for the production of complex and customized parts and components with high level of accuracy and precision. 3D printing has revolutionized the manufacturing industry by enabling faster production time, reduced material waste, and increased design flexibility. It has application in a wide range of industries, including aerospace, healthcare, automotive, and consumer goods. 3D printer use a variety of materials such as plastic, metal, ceramic, and even like living cell, making them a versatile tool for prototyping and production. As the technology behind printing continue to advance its potential to transform the manufacturing industry continues to grow.
Is the flow chart. And then this is the drawing. Linear information data process. The 3D printer process. Design the object. The first step in 3D printing is to create a digital 3D model of the object using CAD software and 3D scanner to preparing the file. The most important idea is to convert the design into a format that the 3D printing can read using software to slice and design into the thin layer and generate G-code file. 3. Setting the printing. The 3D print must be calibrated and set up before printing, include loading the material and setting parameter. 4 is a printing the object. The G-code file is loaded into the printing and the printing process begins depositing layer of material according to the design. And the last one is post-processing. Post-processing is necessary to remove support structure, smooth the surface, and add finished object after printing.
The standard operational process for 3D printing. The first one is preparing the design. Create or obtain a 3D model of the object to be printed using a CAD software. Then the second one is prepare the file using tracing software to prepare the 3D model for printing and generate a G code. And then the third one, set up the printer. Ensure the 3D printer is clean and properly calibrated. And then load the G-code file. Load the G-code file into the 3D printer using a USB drive. Then the fifth one is start the print. Begin the printing process and monitor the printer for any error or issue. Then the sixth one is post-processing. Once the object is printed, remove any spot, structure or excess material as needed. And then a cleanup. Clean up the work area and store any remaining material and equipment according to safety guide.
So parameter process. Firstly, layer height. This refers to the height of each layer of material deposited by the 3D printer. Smaller layer height result in higher resolution prints but can also increase printing time. Next is printing speed. This refers to how quickly the printer moves the print head or bed during printing. Higher printing speed can reduce printing time but may also result in a lower printing quality. Next is temperature. The temperature of the printing material can affect its viscosity, adhesion, and other properties. Adjusting the temperature can help optimize the printing process for specific material. Next is infill density. Refers to the internal structure of the print. Adjusting the infill density can affect the strength and weight of the final print. After that, support structure. Some design may require some support structure to prevent sagging or collapsing during printing. Adjusting the design and placement of support structure can help optimize the printing process. Lastly, bed adhesion. Ensuring proper adhesion of the printed material to the print bed is crucial for successful prints. Adjusting the bed temperature or using adhesion aids such as glue or tape can help improve adhesion.
The advantage of 3D printing. Design flexible. 3D printing allow for a creation of complex shape and structure. 2. Rapid prototyping. 3D printing can quickly produce condi- conditional prototype, allowing for faster design interaction and testing. 3. Customization. 3D printing can be used to create customized objects related to specific need or preference. 4. Reduce waste. 3D printing is additive manufacturing process, meaning it's only use the necessary amount of material. 3. Cost effectively. 3D printing can be more cost effective for small scale produce run. And the last one is accessibility. 3D printing has become more accessible to individual and small business, allow great innovation and creativity in various fields.
These disadvantages is first one is limited material option. While 3D printing has expanded to include a range of material such as plastic, metal, and ceramic, the range of material available is still limited compared to a traditional manufacturing process. The second one is print size limitation. Most 3D printers have size limitation which can restrict the size of the object. And then slow printing speed. 3D printing can be a slow process, especially for a larger or complex object. The fourth one is post-processing requirement. 3D printed object may require post-processing steps such as sanding or polishing. Then design limitation. The design of object for 3D printing may need to follow certain rule or limitation. And then the sixth one is limited accuracy. While 3D printing can achieve high level of accuracy, there are still limitations.
So the defect, first A, warping. This occurs when the material cools and contracts unevenly, causing the printed object to deform or warp. Next, layer shifting. This happens when the printer print head shifts slightly, causing each layer to be printed in a slightly different position. Next, stringing. This occurs when thin strands or filaments are left behind between different parts of the object being printed. After that, over or under extension. This happens when the printer has too much or too little material, resulting in a rough surface or gaps in the print. After that, print through. This occurs when the print head pushes the material through the previous layer, causing a bulge on the surface of the print. After that, Z wobble. This happens when the printer vertical axis is not aligned properly, causing the layer to be printed at an angle or with a wavy pattern. Lastly, infill problem. This occurs when the infill material is not printed properly, causing gaps or uneven area in the material.
And the second last is summary. Non-conventional manufacturing refers to the use, the technique, and process that are different from traditional manufacturing methods, such as machine or casting. These techniques often involve the use of computer-controlled machine, laser, and chemical process to produce parts and components. Some examples of non-conventional manufacturing methods include 3D laser cutting, electrochemical machine, and additive manufacturing. This process can offer several advantages over traditional manufacturing methods, such as increased design flexibility, reduced waste, and lower production costs. However, However, they may also have some limitation, such as lower accuracy or slower production time in some cases. Overall, non-conventional manufacturing is a rapidly evolving field that has the potential, potential revolution the way we make products.
The conclusion is non-conventional manufacturing process such as PDM, wire cut, and 3D printing offer several advantages over traditional manufacturing methods. This process allows for greater design flexibility, customization, and precision, as well as the ability to work with a wide range of material. However, there are also disadvantages, such as limited material option, print size limitations, slow printing speed, and post-processing requirements. It's important to carefully consider the specific requirements of each manufacturing application and choose the appropriate method based on the advantages and disadvantages of each process.